Okay, so here's part 2. We're continuing on. My outside function is to the 5th power. So that's a power rule. Think power rule. You're going to leave the inside function alone. So let's just start with that. Y prime. It's 5 stuff 5 minus 1 is 4. Okay? My inside function, that's outside, we'll say. Inside is x plus x to the negative 1. So that stuff, I leave it alone for the first part. Now I'm going to multiply it by the derivative of this. So let's keep that separate. Derivative of x is 1. Derivative of x to the negative 1, power rule again, negative 1, x to the negative 2. So if I wanted to clean this up, it would be 5 times the quantity x plus 1 over x to the 4th. And then I have 1 minus 1 over x squared. And that's that. Okay, this one has a lot going on because it's got this outside function to the 1/2. That's my outside function. My inside function is all of this stuff, which is a quotient. 1 plus sine t, 1 plus cosine t. So I'm going to have to use the quotient rule here. It's quotient rule. You can think of your rules. And then this one right here is just a power rule. So when you take the derivative of this s prime of t, I can use the power rule. It's 1/2 stuff to the negative 1/2, 1/2 minus 1. Now I'm going to be multiplying times the derivative of this. So this is going to take a little more space. It's going to require, let me just mark this out so that we have lots of room here. So I'm taking the derivative of the inside now. This is, I can just write my inside because I'm leaving it alone here. Now it's going to be the derivative of this, which is low, 1 plus cos t, d high, derivative of the top, derivative of 1 is 0, derivative of sine, we just learned this, is cosine t. Now, it's a minus high, which is 1 plus sine t. D low, derivative of cosine t is negative sine t. I ignore the 1 because it's just 0. Low, low, 1 plus cos t squared. So I'm going to just simplify this right above here. I've got cos t, I'm going to distribute this to both of these terms. So it's cos t plus cosine squared t. And then the two negatives make a positive, but I have to distribute the sine t to both of these. So it's sine t plus sine squared t. Now notice that I have a cosine squared t and a sine squared t. That's just 1 by the Pythagorean identity. And so, and down below, I'm going to just distribute each of these. So s prime of t equals, this is 1 plus sine t to the 1/2, negative 1/2. And then I've got the 2 from this, 1 plus cos t to the negative 1/2. And on the bottom, notice that I have the same thing. I've got 1 plus cos t and 1 plus cos t. So I can actually just add that 2 right there and combine it all, which is kind of slick. Up here, I've got parentheses, a 1 for the Pythagorean identity for these. See that? And that is a 1. And then I've got plus cos t plus sine t. So that, cleaning it up a little bit, we have 2. I put the stuff on top, pause the video to write that. 1 plus cos t t, that's this part, 2 plus negative 1/2, it's 4 over 2, so that's 3/2. And then I'm going to bring this down so it's positive, 1 plus sine, because you might see that in the answer as a final. So we can leave it like that, and it looks good. I remember telling you about this fun special derivative here, and we finally get to see it, see why it's so, because we can use the chain rule, which is very exciting to me. Do you remember when we were talking about exponential functions? We know that e to the x, the derivative of e to the x, is just e to the x. It's proportional to itself, and it actually is. But every exponential function with a base that's greater than 0 is proportional to itself. So there's going to be, if it's b to the x is going to be in the derivative, but then there's this like scalar attachment. So the reason why we have it's the natural log of the base is we have this fancy way, I don't know if you remember, but if you do e to the ln of b, it's actually just equal to b, because that is, e is the inverse of the natural log, and so they undo each other and it's just b. So they take this b, they rewrite it as e to the ln of b, then they have the x on the outside. So now if I look at this derivative, I can use it and think of it as the chain rule. So the derivative with respect to x of b to the x is the same as that, just substitution. And I'm going to use the chain rule. So I take the derivative, my outside function is e, it's just that, e to the stuff, leave the stuff alone, times the derivative of this stuff. The derivative of ln of b x, ln of b is a constant. If you type in the ln of 2, like this answer, that's just it's a number. So it's just the derivative of this, it's just the stuff in front of x. That's like the slope. So then you get this times that, and when you can put this back into the b to the x form, and that's your derivative. And it works for the derivative with respect to x of 2 to the x, so that's the example. It's 2 to the x, remember it's proportional, and then ln of 2, you have to tack on that constant. So for this example, your base, b, is equal to 4. And then the inside stuff, if you want to focus on the inside, it's 4 to the something for your outside. But more specifically, just to keep in mind that b is 4. So when you're following this pattern here, you have your exponential function, because it's going to be 4 to the c over x. You leave that alone. This is the derivative. And then times the inside, which is the c over x. I'm going to write it as the constant times x to the -1. And now I'm going to use the power rule. So it's -1 times c, leave that alone, x to the -2. So it would be negative c, I'm going to put that out front, 4 to the c over x times the natural log of 4, almost forgot that part, ln of b, and then the x squared can go below. Okay, the last example I'm going to show you, it's got a lot of things going on. There is an outside function. This is my outside function. And my inside function is this. So notice that with the yellow, this inside function, I'm going to need the quotient rule, the knowledge of the quotient rule. And there's another inside function which we'll get to. See this e to the 2x? The 2x, you have to take the derivative of that, but we'll get to that. So outside function first. Let's just focus on that. The derivative of the outside function, derivative of cosine, is negative sine. Now I'm going to leave the inside function alone, so you just write it again. And we're done with that. Now it's the derivative of the inside function, which is going to be, we can do our low part at least. That's squared, low. So it's low 1 plus e to the 2x d high, which is the derivative of negative e to the 2x, because the derivative of 1 is 0. This derivative, I've got a negative. I leave my outside function alone. And I know this is a lot. This is like, it's peeling an onion sometimes. You keep taking the derivatives until you don't have any more derivatives to take. So it's e to the 2x, and the derivative of 2x is 2. So you have to multiply by the derivative of the inside of this function. So it's a function within a function within a function. And then it's minus high, which is 1 minus e to the 2x, d low, which is derivative of 1 is 0, derivative of this is e to the 2x times the derivative of that inside function is 2, low, low. There's a nice thing happening here. This I'll show you with a different color. We got e to the 2x is a common factor in this first term, and so is that. So I'm going to yank that out. Maybe I'll take out a negative 2. See this negative? I can think of that as my negative and that negative there. So if I do that, I've got my y prime is equal to, notice that I've got a negative here, sign. I'm not going to write this stuff again. It's there. And then on the second part, I've got 1 plus e to the 2x. All of that's squared. And then I'm going to take out that factor of negative 2. I'll put the 2 in the front, e to the 2x. In the first term, this is just one big term, I've got 1 plus e to the 2x. In the second term, and I canceled out this negative here by taking it out. So now it's plus 1 minus e to the 2x. And what happens? Ooh, that goes away. And then I'm just left with 1 plus 1. So, and notice that these negatives right here and here cancel each other, so we can get rid of those two as well. So my final answer should be the sine of 1 minus e to the 2x over 1 plus e to the 2x. And then I've got times the quantity 2e to the 2x times this and this, which is 2, all over 1 plus e to the 2x squared. I think what I'm going to do right now is I'm going to cancel this 2 and this 2 and just write it as 4, because that'll look nicer and I don't have to rewrite the whole problem. Okay? So let's chain roll with Aretha. Thank you, Aretha. Chain, chain, chain. Chain, chain, chain. Chain rule.